All right. Thank you. Let's work with multiplying and dividing sign numbers. When you multiply things with the same sign or divide things with the same sign, you're going to get a positive result, a positive product. Product is the result of multiplying things. It's just a result of multiplying two things. If you divide two things, then you're going to get a quotient. But either way, if you're multiplying or dividing and your two things have the same sign, you're going to get a positive result. What if they have opposite signs? Good. They're going to have negative results. So a negative product or quotient. Okay, so let's do a couple examples, starting with problem number 24. And right away, I'm going to turn these into more of what I call a Jeff problem. We've got negative 9 times 11, but let's add to that. Let's do 9 times negative 11, 9 times 11, and negative 9 times negative 11. So several different possibilities. And let's see. So 9 times 11 is 99. So let me write 99 for all of these. I want you to tell me positive or negative. So let's just run through this. First one. Second one. Third one. Fourth one. Positive. So negative, negative, positive, positive. Good deal. Let's try number 34. So negative 8 times negative 7. But let me also throw in another one here. Negative 1 times negative 8 times 7. And one last one for good measure, 8 times negative 7. Now in all of these, 7 times 8 is 56. But let's work on the signs here. The signs are the big thing we need to figure out. First one's positive or negative? Positive. Second one? Third one? Good. So what you're doing and what you're getting good at is counting signs, and we're going to go back to that in a little bit. Now this product and quotient rule doesn't work just for nice integer numbers. It works with fractions as well. So negative 3/4 times 4/5. What I would suggest is that let's first determine the sign, and then we'll take care of everything else. It's easy to forget a sign, so let's take care of that first. Positive or negative for my product? Negative. So let's put that negative out front. Now we're done with it. As far as the product is concerned, I suggested this to you last time, that we do some simplification. Where do you see the simplification? Fours. Hasta la vista, baby. Those cancel each other out. What are we left with? Good. 3/5. Now there's a couple ways you could write this. You could write the negative out in front, negative of 3/5, or you can write negative 3/5. You could even write 3 over negative 5. That is, you could put that negative anywhere you want, except this one, mathematically to me, looks ugly, so let's not write that one. But I couldn't mark it wrong. I mean, that is right, but it just doesn't look good. Let's try another one, unless there's some questions on 30. Let's try number 40. Negative 0.7 times negative 8. All right. Well, a couple things. What's the sign going to be? Positive. Good. Sign's going to be positive. You don't have to write a positive out in front. I'd probably prefer not to see it. 7 times 8, we've already done that one. That's 56. But we need to account for the decimals. Now, the way you can work with decimals is this. So there's 1 digit to the left or to the right of the decimal here, and there's 0 here. So there should be 1 digit to the right of the decimal here. Now the way it stands is 56 has a decimal here. So I'm just going to move that decimal 1 place to the left, and now I've got my 1 decimal digit, 5.6. Let's try that again with a different set of numbers. Negative 0.0073, excuse me, 7, negative 0.007 times 0.08. First things first, positive or negative product? Negative, because there's just one negative. So negative. 7 times 8 is 56. But let's keep track of the decimals. There's 3 digits to the right of the decimal here and 2 here. So that means there should be 5 decimal digits in our answer. So let's start here. And then I got to move the decimal left 1, 2, 3, 4, 5 places. Yes. So you're going to have to add some zeros. Now please don't leave it like this. It's a real mess. And I'll probably just mark it wrong. So please just take an extra 2 seconds at most to rewrite it. Negative 0.00056. How are we doing on this one? Did you catch the trick with the decimals? Yeah. Yes, for these smaller, yes, because you have to account for the number of decimal digits that are going to be in your final answer. Other thoughts or questions? Should we do one more like that? Yes? No? Yeah, okay. Let's see. 0.07 times negative 0.00008. How many decimal digits here? 6. So I should have a total of 8 decimal digits here. Start out with the 56. 1, 2. After that, you're adding zeros. So how many zeros am I going to need? 6 zeros. 1, 2, 3, 4, 5, 6. Yeah, let's not forget the negative. Thank you. Because you have a negative times a positive, you're going to get a negative quotient, so or product. So negative 0.0000056. Now, interestingly enough, we don't separate decimal digits with commas. So sometimes, just to make it easier to read, I'll separate things. I'll put a little extra space in groups of 3. You don't have to do that. It's just something I do to try and make it a kinder, gentler math class. All right, hopefully you're getting comfortable with multiplying these decimal digits. Any last thoughts or feedback on the extended problem 40? All right, there's a pattern here with what I'm going to start writing. And let's see if you can be the first one to recognize that pattern. We'll start with negative 1 to the first power. Well, that's just negative 1. But if I have negative 1 in parentheses like that, and I square it, what that means is negative 1 times negative 1. Negative times a negative is going to be positive. The next one, negative 1 to the third power is negative 1 times negative 1 times negative 1. So positive and then negative, so negative 1. Well, the next one is negative 1 to the fourth power. What's negative 1 to the fourth power going to give me? Positive 1. Has anyone spotted the pattern yet?
Even exponents are going to have positive, and all odds exponents on negatives are going to have negatives.
Good. So when you have an odd number here in the exponent, that basically gives you an odd number of negative signs. You're going to end up with a negative product. If you have an even number in the exponent, an even number of negative signs gives you a positive product. So it's a quick way to decide positive or negative. So let's write that down. Even number of negative signs gives you a positive product. Odd number of negative signs gives you a negative product. And it's a nice little shortcut for you. You don't have to sit there and go, all right, that's positive. No, now it's negative. Now it's positive. Just count up the number of signs involved. For instance, problem number 44. Negative 2.2 times negative 4 times negative 5 Let's start with the sign of this. Is it going to be positive or negative? I don't know.
There's 3 negative signs.
Yeah. 1, 2, 3. There's 3 negative signs, so it's going to be a negative product. Now, let's do this as easy as we can. 4 times 5 is going to be 20. So I'll start out there. So I'm going to need to do 20 times 2.2. Well, all right. Let's do it this way. 22 times, it's going to be 440. But let's keep track of our decimals, right? There's 1 decimal here, plus 0 here, plus 0 here. There should be 1 decimal digit in our final answer.
44.
Good, 44. You could write 44.0. I'm not going to complain about that. You don't need to write the 0.0 in this case, but it doesn't hurt. Let's try another one. Problem number 46. Negative 9 times negative 7 times negative 5 times negative 3 times negative 1. Can you see what the author did to come up with this problem? It's got to be a mind-numbing task to write all these problems just to come up with more. Even for myself, I look at that and go, I'm not really interested in being an author. All right, but we got an answer here. So the sign of this is negative because you have an odd number of negative signs. The rest of this, well, maybe we'll kind of chunk it out here. Let's multiply these two together and multiply these two together. So 9 times 7 gives me 63. 5 times 3 gives me 15. Do I have to worry about the timesing the 1? No. And I'm already done with the signs. I'm not worried about the signs there. So all I have to do is worry about 15 times 63. So 945. Yeah, that's right. So 5 times 63 would be 315. And then 10 times 63 would be 630, 945. We already established that that's negative. So we're in good shape. Okay, so let's let me give you another example. Now up here, I had -1 in parentheses, and then I raised it to a power. When you raise something to a power, that means you're going to, multiply whatever in this parenthesis by itself that many times. But it's easy to mix up a couple things. Let me get a new sheet of paper out here. I want to start fresh. Let's take a look at the following two examples and see if they're different. -6 squared and -6 squared. Are those the same? Yes? No? No? What's the bottom one telling me to do? -6 times -6. Good. And that's going to give you 6 times 6 is 36. Is it going to be positive or negative? Positive. How about the top one? Isn't that saying the same thing? No? Why is it different? Yeah, the 2 doesn't distribute itself, or it's not taking account of the negative sign. The only thing that's getting squared is the 6. So this is the negative of 6 times 6, which is -36. So it makes a big difference, right? This exponent here only applies to the 6, not to the negative and the 6. So you have to be careful where the exponent applies. This always brings to mind for me something that used to happen every Christmas. I used to get this catalog offering me, the chance to buy this wonderful t-shirt that somebody thought was really, really clever. And keep in mind, it's coming out near Christmas time. And this was the message that it had on it. What are they trying to say? Ho, ho, ho. But what does it really say? Well, that 3 only applies to the O. So mathematically, it says whoo. Now, if they wanted it right, if they had consulted me, I would have said, all right, it really should be like this. That's ho, 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 right? Because now you got everything. And then a few years later, one of my students said, well, Mr. Parent, how about if you put the 3 out in front? Then you have 3 hoes. I said, well, you got to go down a little Woodward a little ways to find those. All right. Pay attention to where you put the exponent. It makes a difference. All right. Let's do some division ones. Problem number, we'll start with 58, kind of a friendly one. -36 divided by -9. And 68. -2/3 divided by 7/8. The first one should be pretty straightforward. First one is just, divide. Now you've got a negative divided by a negative, so positive. Good. So positive, and 36 divided by 9 is 4. Good. But how about the second one of these? There's a couple things we have to take care of there. Sabrina, what do we have to do when we divide by a fraction? Good. So we're going to flip the second fraction here. So -2/3 times 8/7. All right, good. Then what?
Do you have to change the sign for the second one when you flip it?
No. Good question. You don't have to change the sign on the second one. It's just take the reciprocal. And now we're going to multiply. Is there any cancellation here? No. No. So that's it. Am I going to get a positive or negative product here? Negative. Negative 16 over 21. Is that in lowest terms?
Yes.
Yeah. Nothing. No. Nothing goes into both of these at the same time. So that's in lowest terms. All right. Let's keep going with problem number 92. Negative 3 and 4/15 divided by negative 2 and 1/10. How do you think we should start this one? Yeah, good. Let's start by making them improper fractions. So, was it LaShawn? Yeah, thanks, LaShawn. So, as an improper fraction, what would this be? 3 times that, 45 plus 4 is 49. So negative 49 over 15 divided by what? Yeah, negative 21 over 10. Nick, what happens next? Okay, do we have to find a common denominator? Yeah, not in dividing or multiplying. All right, you don't need a common denominator. So, Sam, I think you hit it right. What's next?
You gotta flip the second equation.
All right, we're going to flip the second one. So, that's going to be negative 10 over 21. All right, Don. What does that give me next? Or what should I do next?
Cancel out the. You need to simplify the 10 and the 15.
Yeah, so there's a lot of things we can do. Let's take care of this first. Is this going to be positive or negative when I... It's going to be positive. If you want to write a little positive there just to take care of the sign and be done with it, that's fine. So, I think a few of you noticed that we can get some simplification. I strongly encourage you to do the simplification. It's going to be a lot easier than multiplying 15 times 21 and dividing that into 490 and trying to put it in lowest terms. Do the simplification first. So a few of you saw that 7 goes into 49 and to 21. Goes into 21 3 times and into 49 7 times. What else is there that'll simplify? Good. 5 goes into 10 twice. Yep. What's our overall product? 14 over 9. Trick question here. Is this in lowest terms?
Yes.
14 because you cannot keep it this way.
Well, yeah, you can make it a mixed number, but it is in lowest terms. There's nothing that goes into both of these at the same time. So on the test, typically all I'm looking for is lowest terms. I don't really care if you put it as a mixed number or an improper fraction. But just to kind of finish this out, for those of you who are uncomfortable with an improper fraction, 9 goes into 14 once with a remainder of 5. So 1 and 5/9. Either of these is going to be fine unless I specifically say I want a mixed number or an improper fraction. Then just give me whatever I ask for. But typically, my biggest concern is that I get something in lowest terms. So, we okay with that? Let's work on the division properties of 0. Division properties of 0. Basically, there's two of them. So 0 divided by some number. 0 divided by some number is 0. And I'm assuming that this number, a, whatever it is not 0 itself. The other way around, though, a divided by 0, that's a problem. You can't divide by 0. Undefined. Cannot divide by 0. I can give you kind of a brief reason for that, brief understanding of one of the problems of that. So if you were to divide, say, 28 divided by 7 gives you 4. How can you check that? How do we know it's right? Well, 4 times 7 is 28, right? Suppose I took 28 divided by 0. And I said, oh, well, that's some number. We'll call it x. Then what I should be able to do is I should be able to check it like I did this one. 4 times 7 was 28. Well, what do you multiply by 0 to get 28? Nothing. What happens when you multiply something by 0? You get 0, right? So there's nothing that's going to make this work. So that's why that's one way of thinking and understanding why we can't divide by 0. We just can't figure out an answer that's going to work there. Okay. So let's take a look at 72. 0 divided by negative 12. And 74. 225 divided by 0. Okay. Amara, what'd you get for the first one? 0. Good. Good. How about the second one? Let me pick on somebody I haven't heard yet from today. Megan? Good. Undefined. Undefined. Nice. Well done. All right. Thank you both. Trying to think if there's anything else I want to mention in this section. I think we're looking pretty good. How are you feeling about the work in this section? You all right there? Okay. Yeah. So for homework, this is section 1.6. Homework begins on page 55. And that would be 19 through 49, 55 through 91, and 103 is underlined in my notes. I can't imagine what that would mean, but it's there. So, all right.